screen. Hope everyone had a wonderful holiday. Great time had by all. Got to see some family. Got to eat some chow. Hopefully, um, we played a lot of games at my house. All my kids were over, and we broke out the board games. Did that Thursday and Friday. Although the girls all went and did a little shopping in the morning on Friday. Didn't get back till middle of the afternoon. But we played games till late in the evening on Friday. And then Saturday and Sunday, my wife had to go to a memorial service for her uncle in Oklahoma. So I was home alone. So I got online, took a test. Now, one of the teacher texts, I had to take a computer programming test. So that's added on my license. But so yeah, I was taking a 3-hour test on Saturday by myself, being proctored over the internet. See, I don't proctor you guys in every test, but this one I had to show the whole room, show there's no notes. Had to have a mirror and show there's no notes on my computer anywhere. Had to show them under the table to make sure I'm not hiding any notes under the table. It was quite a something there, but yeah. So that's what I did on Thanksgiving. I took a test, passed it. That was good. Hadn't studied for it in about 30 years, but I remembered enough to pass it anyway. All right. That's stalling. Got a little bit more. We got 15 of us here. Now we're over 75%. All right. Let's look at what we have due this week. Again, I'll go up to the grade screen. I got caught up on the stuff I was behind on. Thanksgiving, good time to get caught up, right? So I got caught up. Okay, this week, December 4th is Sunday. So this is the 28th. So these two assignments were due yesterday, a week ago, actually, but it was Thanksgiving, so it gave you the 2 weeks. We are looking at properties of logarithms and then solving exponential equations with unequal bases, which also uses logarithms. So these two pair real nicely. We've got 3 more lessons, the Module 4 test, and the semester exam left. So we're getting towards the end. Not much time left. These dates are going to change a little bit. The semester exams, we're actually going to give those to you on the Thursday before finals week and have them due on Monday because we got to get all the grades turned in by Wednesday. So we're not doing the live finals like they're doing in the building where you have to come in Monday, Tuesday, and Wednesday and take hour and a half live finals. We're going to post it on Thursday and it'll be due on Monday. So like I say, these dates will change a little bit to get those things turned in. But let's look at 4.03 real quickly. I'm going to do most of it on paper. I just wanted to go to the Buzz lesson. And let's look at our essential questions. How can properties of logarithms be applied to simplify or solve equations? And the base change property can help in what type of scenarios? So let's go to the pencil and paper. I've got a lot of notes to go through here. Now let's talk about that. It talked about the change of base.
Oh, take notes.
Change of base. Change of base property for logarithms. And basically what that says is if I have log of base b of y, right, whatever the b and the y are, I can take log of y and divide it by log of b in my calculator and calculate that. So what are we talking about? Where's this useful? Well, if I have a problem that says log 3 of 14 equals x, and I have to know what 3 to what power equals 14. Well, obviously, it's not a whole number because 3 to the second power would be 9, 3 to the third power would be 27. So it's somewhere between 2 and 3. Well, I can figure that out by taking log base 10, which my calculator will do, of 14 and dividing it by a log base 10 of 3, which means I don't need to put those 10s, right? Let's look at that. So if I've got log 3 of 14, I can do log of 14 divided by log of 3. So on my calculator, see, all I have is just a log button. I can't choose a different base other than 10. 10 is the only base that it has on. This is just a simple calculator. There are fancier calculators, so you could actually type log base 3 of 14 to figure out what that is. But this is just a simple way to use any calculator. With this calculator, you got to put the number in and then hit log. Like if I hit log, it gives me an error because I have to put the number in first. And so it just depends on your calculator. So if I put 14 and then hit log, that's what log 14 equals. 10 to the power of 1.14612803567 will equal 14. Right. So if I take that and I divide log 3, which is 0.477, the answer is 2.40. 2.4027. Oh, 217. And let's put that far. Now let's check our answer. All right. So if we take x to the y, so I probably have to put this in first. 3 to the power of 2.40217. Hopefully I haven't rounded it too far to where it'll go. Yeah, say that's pretty close. 13.999. If I would have included more decimals, I would have got closer to 14. So yes, 3 raised to this power is 14. So we checked our answer, and that is correct. All right, so that's it. The change of base formula. If you got some weird base and a number, you can just make them base 10. Put the y on top, put the b on the bottom. And that's the change of base. And remember, if you have some weird base, not base, I want to put a log. I'm not writing base here. Log 13 of 13. That's saying 13 to what power equals 13? Well, that's always 1. If these numbers are the same, if the argument and the base are the same number, the answer is always 1. Because any number raised to the first power equals itself. Any number raised to itself equals itself. So 13 to the first power is 13. So that may help you on some problem. They may try to throw some trick question at you. Just remember, that's a quick and easy one. There's no calculations to be done. So let's look at the basic properties of logarithms. Properties of logarithms. Okay, I'm trying to write legibly here. Had a lot of turkey over the weekend, so that's getting hard to do. Properties of logarithms. If you have a log base b of x equals y, okay, bx and y can be any kind of variables. Sometimes it's easier to solve that by converting it to exponents. B is the base, so in our exponent, it's still the base. Y is the exponent. B to the y equals x. These are equivalent to each other. Those are equal to each other. So for example, if we have log base 7 of x equals 2, we're like, man, where do I even start with log base 7 of x equals 2? Well, let's just convert that to this. The base, the b, so that's 7. The y is the exponent, so that's the 2. 7 squared equals x. Oh, that's not hard at all then, right? X equals 49 because we just take 7 times 7. So in this case, log 7 of 49 equals 2. So we were able to solve that logarithm problem by converting it to an exponent, and then it got real easy because 7 squared equals x. We can put that in our calculator if we need to, if we can't do 7 squared in our head. But that one comes real easy. So that property of logarithms, knowing how it converts back and forth to an exponent, is very useful in solving a lot of these problems. Let's look at this is a good one. The equality property of exponents. Okay, this one's real handy to use sometime. And this was one of those, some of these are kind of like, well, yeah, no duh, right? This is like a duh property. If I have log base b of x, and it is equal to log base b of y, then x equals y. It's that simple. If they have the same base and they're equal to each other, well, x and y have to be equal to each other. There's no other way to do it. If I have log base 10 of x, and this is log base 10, 2, well, x has to equal 2. These numbers have to be equal to each other for that to be a true statement. X could not be any other thing, and that be true. So the equality property. All right, so, but yeah, it's like, well, of course that has to equal 2. It's one of those that's just pretty simple on that. Let's see. Let's look at the product property. Product property. So if I have log base b of x plus log base b of y, that is the same as log base b of xy. If you're adding two logs together, it's the same as just multiplying their arguments. Log b of multiplying the arguments. Let's look at that as an example here. Log base 7 of 3, which 7 to what power equals 3? Well, it's less than 1, plus log base 7 of 5. That's the same thing of calculating log 7 of 15, because we take 3 times 5. The G looks funny. Multiply 3 times 5. If we have the same base, again, the same base is important. So log base 7, 3 and 5, we can multiply them together, and that would be equivalent. So then if we want to calculate that, 4 to what power equals 15? Well, 4 squared is 16, so it's less than 2. We can put it in our calculator as log 15 divided by log 4. Don't forget that change of base thing. That change of base is very useful. So let's put that in our calculator and see what that looks like then. Log 15 divided by log 4. Clear. 15 log divided by 4 log. There you go. 1.95. 1.95. We'll go 4 decimals this time. 1.9534. So if we want to check that, it's not going to be exactly right because it's not going to be exact 15 because we rounded it. If we could keep that whole number, it would work. But let's see. So let's clear that. And we say, all right. So we're saying 4 to this power equals 15. 4 to the power of 1.9534. 14.999. See, we'll get the rounding error from, we'll never hit 15 exactly unless we put a whole lot more numbers. But that's going to be a right answer. That's how that works. While we're here, let's look at the quotient property. All right. Products when things are multiplied, quotient in mathematics when they're divided, right? So, and this is saying, let me get rid of that calculator. Quotient property. So if we have log base b of x minus log base b of y, that's the same thing as log base b of x divided by y. Sure, it's a y, not a 4. X divided by y. So let's put that in practical use here. Let's go log base 7 of 40 minus log base 7 of 8. That would equal log base 7 of 40 divided by 8. Here we can go ahead and write it out. Equals log base 7 of 5. And again, if we need an actual answer, sometimes they just want you to convert it, do this. But if you want an actual answer, we use this change of base property, log 5 divided by log 7, and it'll give us a number, which will be less than 1, because 7 to the first power is 7, so it's going to be smaller than that. All right, so that's the quotient property. Let's look at the power property. I got the power. Okay, there's the power property. So the power property is log b of x raised to the power of y is the same thing as y times log b of x. We can just take that y and put it right out front and multiply. Take y put out front, y times log b of x. So of course, if we want an example of that, log 5 of 6 to the third would be the same thing as 3 times log 5 to the 6th power. Rewriting it to where we could do it. And then we can put this in the calculator, log 6 divided by log 5. Take it times 3 and we'll have our answer. The power property. So knowing these properties, and these are great for your notes. They're in our lesson. I would have these written down somewhere. I would have this definitely written down. If these are the same. Definitely you want to know the change of base. All important to have in your notes. So you know what you're doing when you take the tests. The equality property. The product property. You know, I would have all of these things in notes, the quotient property, just so I know what to do when I run across these in problems, rather than trying to remember it all. And then the power property. All right. So with that, that's lesson 4.03. Lesson 4.04, we'll look real quick in the. It's solving problems, right? Solving exponential equations with unequal bases. And it's going to use some logarithms to help solve some of these. And we're also going to look at this. Remember, we learned how to figure interest, like putting money and investing. We're going to be using that, but we're going to use it a little differently to answer questions. So how can exponential equations with unequal bases be solved? And how do the various parts of an exponential equation affect the entire equation? So let's look at that. Some examples I have here. I mean, first of all, the most simple, when we have 2 to the x equals 8. Okay, let's look at exponential. We're not in logarithm at this point. We could do this with logarithm, but first let's look at this. In order to solve this, we need these to be the same base. This is base 2, this is base 8. In this case, 8 is 2 to the third power. 2 times 2 times 2 is 8. So that means we can rewrite this as 2 to the x equals 2 to the third. And anytime you have the same base, we can just set these equal to each other. X equals 3. That's the only thing it can be. If 2 to the third is only going to equal 2 to the third, that has to be a 3. All right, but this could be solved if we had something that wasn't quite so simple, right? This is a pretty simple one. 2 to the x equals, let's say we had 4 to the x equals 7 to the x plus 1. We can't make those the same base. We can't make those a power of 2 to the anything, 4 to anything. These are different. So I want you to, sometime this week, this is in our lesson, there's a video. There's a video that shows how to do this. And you can try it on your own before you watch the video if you want. We can do the same problem with logarithms. We can say, okay, if 2x equals 8, then the log of 2x equals the log of 8. If this is true, then this is true. We take the logarithm of both sides, and those are equal. We're taking the logarithm of two equal things, so those have to be equal. The logarithm of two equal numbers has to be equal. So looking at our properties, we know the power property right up here. We can rewrite this. So that's the same as, I'm sorry, not the 2 first. X is the exponent. So x times log 2
Oh, I put 24 instead of 27.
equals log 8. So we can rewrite that, divide both sides by log 2. So x equals log 8 divided by log 2, which equals what? Well, let's see. So 8 log divided by 2 log equals 3, which is the same answer we got up here, right? Same answer. We just did it with logarithms. We rewrote that using the power property. Then we isolated x by itself, divided both sides by log 2, and put that in the calculator and got the same answer. So again, you can do a problem that you cannot do otherwise. Excuse me. You can't make them the same base. You can use logarithms. Log of 4x equals log 7 of x plus 1. So little tips on how to solve some pretty complicated problems, right? All right, let's look at, got to remember there's the natural log. Remember, we're talking about E. E is a number in math. E to the 2x equals 30. Wouldn't even know how to start to solve that. But we can take the logarithm of each side. So the logarithm of E is the ln, is what they use on the calculator, which means it's base E. We don't write that, but ln is always base E. E to the 2x equals 30. So if we rewrite that, 2x times ln E of E equals 30. Remember, anytime you get the base and the argument the same, this is just going to equal 1. E to what power equals E? E to the first power equals E. So this is just 2x times 1 equals 30. X equals 15. Hey, how about that? There you go. X equals 15. So 2x. Oh, I'm sorry. It doesn't equal 15. Mr. Brock made an error. I said you just take the log of both sides. I didn't take the log of this side. I'm going to take the log of that side. I have to take the log of this side. 2x equals the log of 30. X equals the log of 30 divided by 2. The natural log. This is the natural log, ln. So that we will have to put in the calculator. So 30 natural log divided by 2. So this equals about 1.7. I'm going to say about is a little squiggly. 1.7. 0.00598. So that's about what it equals. So take that times 2, e to that power will be about 30. That makes more sense. Yeah, got to take the log of both sides. Mr. Brock messed up. All right. So that's how you can use logarithms to solve problems and those properties that you should have in your notes, or you need to put in your notes. Let's look at one more thing here. Let's talk about this interest formula, right? A equals principal. We've used this. We'd use this to say, all right, I got $50. I got a bank account that's going to pay me 3%, and it's going to give me the interest monthly. And usually we say, for 10 years, how much money do we have? Well, we're going to do something differently. We're going to put a goal. Our goal, let's say you got $50 for your 16th birthday, and you're going to put in a bank account, earns 3% interest, and it's going to get interest every month. And your goal is like, how long till I have $2,500 because I want to put it down on a car? I want $2,500 for a car. So how long do I have to leave this $50 to bank until I have $2,500? Well, that's a different problem than before, because now the A, we know what the A is. That's the goal. That's the amount we want. And we start with $50. 1 plus the rate is 0.03. Remember, we have to have that as a decimal. Divided by the number of times each year I'm getting interest, 12 to the NT. 12 time is what we need to know. How many years? 12t. So if we got this 0.03 divided by 12, so we can simplify that. 2,500 equals 50 times, what's 0.03 divided by 12? Let's do it in our calculator, make sure we don't mess it up. 0.03 divided by 12 is 0.0025, and then we add 1 to it, plus 1. So in the parentheses is 1.0025 raised to the power of 12t. Raised to the power of 12t. So if we want to solve this, we need to know what time is. We can divide both sides by 50 because we got that 50 right there. So 50 equals 1.0025 to the power of 12t. So I don't have to have the parentheses necessarily anymore, but I can put them on there just to clarify. That's being raised to the power. Oh, let's get rid of that. Divided both sides by 50. 50 equals this to 12t. Well, now we've got one of those problems that we're trying to solve. It's an exponential problem that we can just go with the logarithm. So log of 50 equals log, got to take log of both sides, 0.0025 to the power of 12t. All right, so we can use our power property again to rewrite this. Log of 50 equals 12t times the log of 1.0025. Okay, so we're getting closer. Let's divide both sides. We're trying to get this t by itself ultimately. So we'll divide both sides by the 1.025, 2 zeros. Log 1.0025. And that will equal 12t. So we're getting down to, we're going to need our calculator. Log 50 divided by log 1.0025, okay, equals 12t. So let's get some numbers here. Let's put our calculator back up. Okay. All right, so a calculator, we're going to take log 50, which is that 1.69897, and divide that. I don't want to round this if I can avoid it till the very end. So I'm going to leave that whole number. I'm going to divide it by 1.0025 log. So there's what it equals when I divide it, 1,566.764. And then the last step I would need to do is divide by 12. Right? Because we got 12t. So since I got 12t, divide that by 12. Oh, my calculator just disappeared. Oh, cancel that. Okay, don't know what that is. All right, so divide both sides by 12. So whatever this answer is going to be divided by 12. And here's what our answer is. T equals 130.56 years. So if you got $50 and you put it in the bank, making 3% interest every month getting paid for 3% interest a year. In 130 years, you'll have enough for that car payment, that $2,500 monthly goal that you had for that down payment on a car. 130 years. You might need to put more money. I don't think that $50 will get you there. So, but that's how we can figure out how many years it would take to get $2,500, starting with $50, 3% paid every month. Logarithms. They do have very useful uses because we would not be able to calculate that otherwise. That would be a lot of work trying to take this statement right here and come up with an answer. Right? That's going to be a lot of work to calculate. I mean, if we just start guessing, oh, what if t equals 1? So 1.025 to the power 12. Nope, that's not it. What if it's 2? That's to the power of 24. You'd have to go all the way to 130 before you'd get it. And then it's not a whole number. It's not an integer. It's got that decimal attached to it. So that is an overview of the 2 lessons this week, using the properties of logarithms to be able to solve exponential equations. So make sure and put all those logarithm properties in your notes. Have them handy. So when you take the test, when you take semester final, any of that stuff, you've got it. Assuming you have to take the final. You can exempt Algebra 3. That is exemptable if you don't have too many absences or don't have any missing assignments and whatever all those rules are, right? Rules. But anyway, that's it. You have those 2 assignments this week. Go through those lessons. Like I say, find that video on how to do that 4 to the x equals 7 to the x plus 1, whatever that was. But go through there. I gave you a nice summary, but there are more details in the lesson. So you still need to go through the lesson. And some of this you'll already, okay, Mr. Brock did that. I understand that. But there'll be some other stuff that will explain it further, in addition to lots of practice problems. 4.03 has lots of practice problems. And if you don't practice this, you're not going to be able to do it. If you just write in your notes and say, all right, I know how to do it for the test. No, you won't. If you don't practice it, you're going to get lost when you get a test. Oh, how did this work? Do the ones in the lesson. Do the practice problem in the lesson, because that lets you check your work. It'll tell you exactly all the steps. So you can see, oh, I missed that step. That's why I got it wrong. That's important. That's how you succeed in virtual algebra 3, is to do the practice problems when available. So, all right, I'll let you guys go. Have a great week. I'll see you Wednesday or Friday if you need to be here. Oh, Friday's a B day. Friday's a B day. I'll see you Wednesday if you need to be here. Otherwise, have a great week.